Hello everyone. Now it's my turn to present my paper. First of all, I would like to introduce myself. My name is Muhammad Fariz. Just call me Fariz. I'm from the Faculty of Architecture, Planning and Surveying, University Technology Mara. The title of my presentation is Displacement of My RT Stations After 8.6 Magnitude Earthquake of North Sumatra 2012 using GNSS data. Before we go through, I would like to tell about my presentation outline. My presentation will be divided by 5 sections. The first section, I will go for the introduction. Then, second, I will tell about the scope of my study, of my research. The third, I will explain the methodology of research. Then, at the fourth section, I will show the result and the discussion based of my research. Finally, in section 5, I will conclude my presentation of my research. First, we go to introduction. Sundaland. Sundaland is a continental and maritime region also known as Sunda Plate located on the zone of convergence between Indian, Australian, Philippines and Eurasian plates. North of Sundaland is bounded between a collision zone of Indian-Eurasian plates and South China Block. The vast majority of geodynamics in Sundaland occurs in this surrounding plate subduction and collision zone. 11 April 2012, on 8:38, an earthquake occurred about 610 kilometers southwest of Banda Aceh, Indonesia. The depth of the earthquake had reported 22.9 kilometer depth in the Indian Ocean according to a scale used by United States Geological Survey (USGS). The magnitude of the earthquake was 8.6 magnitude. Epicenter of the earthquake is located within the Indo-Australian plate, which is divided into 2 sub or protoplates. That figure shows that Malaysia is closest country after Indonesia from the epicenter of the earthquake. After the earthquake occurred, the North Sumatra Tsunami Alert had issued by the Pacific Tsunami Warning Center and cancelled a few hours later. In Malaysia, some states, which is Penang, Kuala Lumpur and Kedah, reported the tremors was felt reported Malaysia. The study investigates the MRT station calls will use GNSS data for a period of 1 year from day of year 001-2012 to day of year 366-2012. The RTRF 2014 was deployed by applying a minimum constraint approach for reference frame definition. International GNSS service (IGS) stations all over the world were utilized during the reference frame definition process. The IGS stations play a significant involvement in relative GNSS positioning. The scope of analysis was limited to study the deformation of my RT station after the earthquake. The figure shows the RT call station network location throughout the Malaysia. GNSS data for all these my RT calls is used in this study. Next, I will explain about the method that I used in this study. This is the flow for GNSS daily solution processing. First, apply the MyRTCanet calls data from Geodetic Survey Division, Department Survey and Mapping of Malaysia. Then, prepare the data to ready for pre-processing. For data preparation, I check the station name and renaming it as recommended from the Bernie software. Check the station information file. Make sure the antenna type, receiver type in the observation file are same in the software. Then handling of station problem and station type if needed. Check the station coordinate and velocities of station in the software is updated. Then download the IGS station Rhinex data from the website. Next is pre-processing. The SP3. The SP3 is standard product 3. Orbit format is widely used around the world for exchanging precise GNSS orbit data. ERP is an abbreviation for Earth Rotation Pole. A time series of pole coordinates and their length is contained in the pole files, and this information is required in order to carry out the transformation between the terrestrial and the celestial initial reference frames. The cluster deformation caused by the change in mass distribution caused by the ocean tide is another important relocation effect. It's called ocean tidal loading. The ocean tidal loading data can download at www.noaa.gov. SP3 and ERP can download it from aiub.unibe. Next is the process data using the double difference method. The study is processed by the double difference solution to have the adjusted coordinates. The GNSS data were processed by using Bernis Scientific GNSS processing software version 5.2 in daily batches at 30 seconds intervals with a cutoff elevation angle of 10 degrees. Double differencing is accomplished by comparing station to station and satellite to satellite differences in order to eliminate cycle slips in the observed L1 and L2 carrier signals recorded by the receiver. Next, we go to the result and discussion. Based on the GNSS data processing strategy as mentioned before, daily processing was applied to all the multi-coordinate stations. The figure shows the time series coordinates from daily solution for northern region, it's Arau. From the time series plot shown, the graph was slipped in the eastern part at the moment of the earthquake was held. Next, the figure shows the time series coordinates from daily solution for central regions, T low. From the time series plot shown, the graph was slipped in eastern part at the moment of the earthquake was held. Next, we take a look at the figures shows the time series coordinates from daily solution for southern region, TGPG. From the time series plot shown, the graph was slipped in eastern part at the moment of the earthquake was held. This is an example for the Borneo region. The figure shows the time series coordinate from daily solution for Borneo region, station Sema. From the time series plot shown, the graph was quite stable compared from the peninsular station at the moment of the earthquake was held. Let's take a look at the figure. The figure had shown the movement of my Arctic station's consequence from the earthquake of North Sumatra on 11 April 2012. The result also showed that Peninsular Malaysia was affected more than Sabah and Sarawak. The displacement of Peninsular Malaysia was moved to the east. The central region of Peninsula also affected, but not greater than the northern of Peninsular Malaysia. Let's take a look at the table. Let's find out the table in this slide. It showed my Arctic station in northern region of Peninsular Malaysia is most affected. Take a look at Toka. Okay. TOCA showed the magnitude about 4.48 centimeter. It followed by USMP about 4.47 centimeters, and the most west station in Peninsular Malaysia is USMP. Just take a look at the table central region of Peninsular Malaysia. In this study, the station that affected after the earthquake is the north station of the central region, referred to Greek station. The magnitude of the station after the earthquake was 4.56 centimeters. It followed by Lhasa station, and the magnitude is 4.33 centimeters. The result from the southern region of Peninsular Malaysia can be referred to the next table. Take a look at the PDIC station. PDIC station is the most affected after the earthquake, but the magnitude is not greater than the northern region. Magnitude of the PDIC station is 2.96 centimeters. Follow the PDIC station is KLAW station. The magnitude of the station after the earthquake is 2.83 centimeters, and the magnitude is getting smaller to the south of Peninsular Malaysia. Let's take a look at the Borneo region of Malaysia table. On the right, it's not moved significant. The greatest magnitude that in the region is Niah station. It was only 1.21 centimeters. It looks like Borneo region is not significantly affected from the earthquake of from the earthquake of North Sumatra on 11 April 2012. So, in section 5, my conclusion. Based on the processing and the result, this research can be concluded that earthquake on North Sumatra had affected at Peninsular Malaysia. The most displacement is the Greek station, where the magnitude is 4.56 centimeters and the direction 0.32 to the northeast. Although the station is in the central region in my study, Greek station, situated is the most north of the central region. Follow the Greek is the TOCA station. The station is in the northern region of Peninsular Malaysia. The magnitude of the displacement is 4.48 centimeters and the direction is 1.57 to northeast. In southern part of Peninsula, the most displacement of the station is 2.95 centimeters in magnitude and 0.1 to the northeast. It was PDIC station. PDIC is situated the most of the north of the southern part of Peninsular Malaysia. In this study, the less affected is Borneo region. The most displacement in the Borneo is Niah station. It was 1.21 centimeters magnitude and moved 0.41 to the southeast. Though the displacement of Peninsular Malaysia was not greater, but it affected the coordinate of my Articanate station. When the coordinates is affected from the earthquake, the coordinate system will be affected also. For the next step, GDM 2000 must be revising and come up with the new parameter of the coordinate system in Malaysia. That's all from me. Thank you for an attention to my presentation. I hope you enjoy with my presentation. Feel free to contact me if you have any question or want to share knowledge. Thank you.